Well, let me show you what I'm going to do, and then I won't make you watch me type them all in. I'm going to type these into L1 and L2. So I'm going to go over to Stat, into Edit. I've got stuff in L1, so I want to clear that. So I'm going to highlight L1, hit Clear, and hit Enter. And I might as well go ahead and clear L2 while I'm here. If you accidentally, there's some way where people will accidentally delete one of the lists. It just disappears. If that happens to you, you come here, you go Stat, and Set Up Editor. Just hit that, hit Enter a couple of times, and that will bring your L1 back if you accidentally deleted it completely and it doesn't show up on your screen. All right, I'm going to type all of these into L1, all these into L2. I'll pause so you don't have to watch that. Okay, so I got them all typed in. Now, these are not paired data, like they don't go together. So I don't have to worry about, like, if I forgot to put in the 45.7, it doesn't have to live right next to this one. It can go anywhere in the list. Say either list. You can put them in any order. I mean, obviously these numbers need to be in this list, but you know what I mean. Okay, now there's nothing wrong with this. I could go Stat over to Calculate and do one variable stats and say choose L1. And there's my sample mean. There's my sample standard deviation. I could write those down and do this problem exactly like I did the last one. Same thing with L2. But I don't have to. Our calculator's smart. What is it we're trying to do here? We are trying to do a hypothesis test. Okay, so let's write down the stuff we need to write down, and then I'll show you how to do this on the calculator. First thing we got to do, define our variable. Let mu be the mean temperature. Then we had group 1 and group 2. We've got Memphis and Detroit. And they tell us that this is list 1. They chose for us that Memphis is group 1 and Detroit is group 2. I would not have done it that way, because Detroit ends up having the higher mean, but doesn't matter. I'm typing these wrong. And 1. We don't know any of these numbers yet. I mean, you could see I did actually just find them for Memphis. I could write them down if I wanted to, but we don't have to. Like, it'll tell us all that at the end. Hey, we write our hypotheses. They tell us to call this guy group 1. Our null hypothesis is always mu1 minus mu2 equals 0. Now, you'll see some of the homework problems, they'll do stuff like this. They'll do like mu Memphis is less than mu Detroit. Instead of calling it 1 and 2, they'll put subscripts on it, which is perfectly fine. And you'll also see that on some of the homework problems, let me write up our alternative here. So we chose less than here because Memphis was less than. See, they say that here. Memphis is less than Detroit. And they made us choose Memphis as group 1, so I have to put a less than here. Now, of course, I could have just as easily said the two are equal and mu1 is smaller for my hypotheses. Now, what I wanted to point out is you'll have some of the homework problems. It's an alternate way to do it. Instead of making this one equal, what you're trying to test is forced by this. The problem said less than, so I had to write less than here. So some people then will say, well, if that one's less than, this one must be greater than. So you get a less than and a greater than. In every problem that alternate way to do it. One of them has a less than, the other one has a greater than. This one always has the equal to on it. I think that confuses students more. So that's why I always just put equal on the null hypothesis. It's just an alternate way to write it up. And you'll see that, like here, you can see in some of the homework problems, like this one, that's how they're doing it. Like the right answer there. See, we're using those subscripts instead of 1 and 2, has a less than on the null and a greater than on the alternative. I should probably just, for future generations, edit this question to make it look more like the ones we're doing. But look, you might run into this in the real world. Some people write these up a little differently than we've been. And it's still perfectly valid. Okay, now that we got all this, the calculator is going to do all the work for us. So this is a 2-sample hypothesis test. That's button 4. 2-sample test. And I know the data. I know all my data points. So I'm going to highlight data and make sure these say L1 and L2. If they don't, if it were L3 and L5 or whatever, see, I got my little L's there. I could go second, L3. But that's not what we had. We had L1. Leave these alone, frequency lists. My alternative hypothesis was less than. See, I wrote right there, less than. Always leave pooled on no and hit calculate. That's my test statistic right there, the t-score. And that's my p-value. I personally don't care about the test statistic. I'm not going to ask for that on the final or any written exam, but some of these homework problems, or maybe even a test question, you know, the MyOpen Math test might ask for it. Here's our p-value. That's what we care about, 0.0018. That's less than alpha. I don't even know what alpha is. I don't care. That's smaller than any alpha we're going to use. But alpha was 5%. So that means we can reject the null, accept the alternative, which says what? Says that group 1 is on average less than group 2. So we would say we have strong evidence that the mean temp in what was group 1? Memphis? Is it Memphis? Yeah. Is less than the mean temp in Detroit. Which is, like you can see here, I've shown all the correct answers.